Welcome to qnawire.
For part A, we can treat blocks A and B as a combined system, in which case we have the force diagram of a force of friction to the right, a normal force upwards, a force being pulled on to the left, and a weight force downward. Doing Newton's second law in the y direction, which we know is equal to 0, implies that N is equal to the weight, which is equal to 4.8. Remember, this is the combined block system, so we have to sum the two weights. This means that Fk, the friction force, is mu k times the normal force. It's equal to 1.44 newtons, after you multiply 0.3 by this 4.8. Now doing Newton's second law in the x direction, which gives us 0 again because these blocks are not accelerating, they're moving at constant velocity. This implies that the force we apply is equal to the friction force, which is equal to 1.44 newtons. And so that's the answer to part A. In part B, it helps to draw the force diagrams first. So for block B, the force diagram is fairly complicated. There's a normal force going up. There's a friction force here. There's another friction force between the ground and block B. So there's two friction force. One is responsible between A and B, and then the other is between B and the ground. There's also a weight force of block B. And there's also a normal force from block A now being put down on block B. And there's also our force that we're applying to the left. For block A, the force diagram is a little simpler. We have the normal force just due to the weight of block A. We'll call it NA. We have the tension in the rope to the right. We have the weight of block A downward. And we have the friction to the left. Now the friction here is the friction between A and B, and the same thing here. And so they form a Newton's third law pair. So FKB equals FKA. And actually they're opposite in direction. So instead of saying the vectors are equivalent, I'm going to take the opposite value and say that their magnitudes are equivalent. Also, NA is equal to NB for the same reason. They form a Newton's third law pair and thus are equivalent in magnitude. Now, we're going to apply Newton's second law in the y direction, and we're going to apply it for A, for block A. And that implies that NA is equal to the weight of A, which is equal to 1.2 newtons. This implies that FKA, the friction force, is equal to mu k NA, and then plugging in the values 0.3 and 1.2 here, we get 0.36 newtons for that friction force. Again, this implies that F of KB is equal to 0.36 newtons, since they form a Newton's third law pair. Now Newton's second law in the x direction. For A gives the tension is equal to FKA. And we just found out what FKA was. It's 0.36 newtons, so the tension must also be 0.36 newtons. Now we're going to apply Newton's second law again, except we're going to apply it for block B, and we're going to do it in the x direction. For B this time. This gives the force that we apply is equal to this friction force plus this friction force. We've already calculated what those two friction forces are. They're 0.36 and 1.44. And so the combined force that we have to apply is 1.8 newtons. And that's the final answer to the